Direct Connection is made by MPT to serve all of our diverse communities and is made possible by the generous support of our members. Thank you. Live from Maryland Public Television, this is Direct Connection with Jeff Salkin.
Good evening. Welcome to your Direct Connection. Coming up tonight, answers to your questions about this, the first image of a black hole millions of light years away. But first tonight, your chance to see an Eastern Shore rocket launch, the space station resupply mission due to lift off on Wednesday from Wallops Island, Virginia. Joining us live now is NASA's Dave Pierce, director of the Wallops facility. Dave, thank you for being with us. Tell us about this flight on Wednesday.
Hi, Jeff. It's my pleasure to be with you. The launch will take place around 4:46 in the afternoon, and folks who want to come out and see it need to come down south of Salisbury and turn on Virginia 175, Route 175, and head to the Virginia NASA Wallops Visitor Center, where we have a viewing area and we have all the necessary information, including a countdown clock, so that folks can be really comfortable and get a good bird's eye view of the launch on Wednesday.
Dave,
the weather looks great.
Dave, I was going to say, we have a graphic of sort of concentric circles coming out of Wallops, where theoretically somebody could see this from the Beltway region, but maybe better with a night launch than a day launch?
I would think so, but even still, they'll be able to see it launched, say from Washington, to be able to look in the general direction as that graphic is showing toward the south by southeast. And they shouldn't have any trouble seeing it around 4:46 p.m.
How close do you let people get there on the facility?
From part of the viewing area, from the visitor center, is going to be about 4.5 miles. And that's just a great, close-up view. As a matter of fact, as the rocket launches from Wallops Island, folks at the visitor center will be able to see the trajectory and the profile of the Antares rocket as it goes into space. So it's a wonderful track to see. From behind, there's an area that some of the NASA researchers will be located. It's about 2.5 miles away.
All right, let me help people understand where the rocket is in the shot of Dave that we're looking at. So over your right shoulder, so upper left part of the screen, you see the base of a water tower, actually, and in front of that is the rocket. And the rocket is notably not pointing up at the moment. It's in a horizontal position. I assume, Dave, you're going to tilt it up before you fire it off.
That's right, Jeff. So today, as you well know, in the Maryland and Virginia area, it's been quite windy. As the winds die down through this evening, the Northrop Grumman crew will erect the launch vehicle, and throughout the morning tomorrow, we'll do end-to-end checks. They'll hook up all the umbilicals, and they'll do a complete checkout of the launch vehicle to make sure it's ready to go. Later in the day, they'll lower the launch vehicle back down, and then they will conduct what they refer to as a late load. This is where we bring in supplies and experiments that are going to be done on the International Space Station. Once that capsule is put back on, then they'll erect the launch vehicle again and be ready for the launch around 4:46 p.m. on Wednesday.
Let me remind our viewers, if you have any questions about Wallops launching rockets from the Mid-Atlantic area, give us a call. We'll have the number up on the screen. You can also email us a question. The email address, livequestions@mpt.org. Dave, what is the deal with launching from, this is pretty close to the Maryland-Virginia line on the Eastern Shore. We're familiar with rockets being launched mostly from Florida. Is it easier or harder to get to the space station from here?
I think that the launch location from Virginia is ideal for reaching the space station. The Antares rocket will launch and it will go into an orbit below the space station. The space station will be about 250 miles above the Earth. And the Antares Cygnus spacecraft, which carries all of the supplies. And for this launch, Jeff, it's about 7,500 pounds of supplies, one of the largest loads that we've ever launched from Wallops. And once it's in that orbit below the space station, then over a couple days, the Cygnus spacecraft will chase down the space station, rising in altitude until it comes to within an area to where it's grappled by a robotic arm and then pulled into the space station where it's then locked in and then unloaded. So it's an ideal location from Wallops to support commercial resupply of the International Space Station. And as you know, commercial resupply at Wallops through Northrop Grumman has been going on for almost 8 years now. But the idea of a commercial spaceport started about 25 years ago when leaders at NASA wanted to promote commercial access to space. And they created a spaceport with the state of Virginia and Maryland to create the Mid-Atlantic Regional Spaceport. And that's where we're going to launch Antares from.
Let's take a call from the Eastern Shore. This is Colin in Queen Anne's County. Colin, go ahead with your question.
Oh, I think it's sort of been partially answered. I was asking why was Wallops so a special spot to have launches?
Very good.
And then I didn't know what the function was this time, but I think we've been told about it.
Thank you very much for the phone call. And the early history there, Dave, goes back to the 1940s, I think.
That's right, Jeff. So rocket engineers at the end of World War II came from Langley Field in Hampton, Virginia, out to the Virginia Cape to launch rockets to test advanced aerodynamic shapes that would become later jet aircraft. That led to about 60 years ago of Wallops being crucial in the formation of or the development of the crew capsules to go to the moon in the 60s. And then so, you know, we've had a long history here at Wallops of supporting manned human exploration. And we're really excited about what we've learned from commercial space and it's serving as a linchpin as we set forth to return to the moon and land next humans on the moon on the south pole of the moon in 2024.
Let me come back to the best place to watch, because I haven't been there for decades, I'm sorry to say. But the surrounding area, of course, there's Chincoteague. Assateague isn't that far away. There's all sorts of little nooks and crannies. I'm sure you have a big exclusion zone for boats and aircraft, but can people get to a similar distance, that 4 or 5 miles, and still be off base?
Yes, if they all go to the Wallops Flight Facility webpage at nasa.gov and they look for the Wallops Visitor Center webpage, they'll be able to see launch observation areas that they can go to.
Very good. Dave Pierce running... I'm sorry, go ahead.
And some are going to be close to Atlantic, Virginia, Jeff, and then some are closer to Chincoteague. But the beach on Assateague has been closed.
Very good.
But we really recommend that they go to the visitor center.
We will warn the horses. This is Dave Pierce, who runs Wallops for NASA. Dave, thank you very much. And coming up tonight, what's so significant about a fuzzy orange donut? That's next on Direct Connection.
Got an unused vehicle going nowhere? Donate it to the one place that can take you any place. Visit mpt.org/vehicles and support the programs you love on MPT.
The MPT app puts our programs right at your fingertips, so you can choose when to watch, what to watch, wherever you want to watch it. Download it now.
Are you turning 70 and a half this year? If so, you generally have to start spending down your retirement account. Even the minimum distribution can place you in a sticky situation. Luckily, you can now use your IRA to make tax-free gifts. Gifts up to $100,000 will never count as income, but always make a difference. That's icing on the cake.
Make your gift for this year before December 31st. Visit mpt.org/support.
This is a box that showed you a world beyond your own. It was just a box, but the world has changed, and so have we. And now the box can be almost any size or shape. And you decide what you want to explore. Anytime, any place. Break out of the box with PBS.
We are the curious.
Wow!
The adventurous.
Oh! Those venturing out for the first time.
And those who've never lost our sense of wonder.
Whoa!
You seen this?
We are the hungry.
The strong.
I must be the greatest!
The joyful.
A happy little cloud.
We believe there is always more we can uncover.
More we can explore.
We believe in the capacity for goodness.
And the potential for greatness.
The torch has been passed to a new generation of Americans.
PBS.
PBS.
Astronomer Roland Vandermarel from the Space Telescope Science Institute joins us here in the studio. Sir, thank you very much for the time.
Good evening.
We're here to explain black holes in 10 minutes.
Yep.
Good luck. The reason we want to talk about it is there's this new photograph. For the first time, this image has been put together of a black hole millions and millions of light years away. Let's start with what that gap in the center of the donut is there. What is a black hole?
Right, so a black hole is an object in the universe that is so small yet so massive that its gravitational pull is so intense that nothing can escape from it, not even light. That's why we call it a black hole.
We think about gravity in terms of Earth. If I hold up my phone and drop it, it bangs on the desk. This is infinitely more powerful and compressive?
Well, actually, to make a black hole, you don't really need anything special. You could take the Earth and turn it into a black hole. All you would have to do is you would have to squeeze it into about the size of a marble. Now, that's of course very hard, but there are actually places in the universe where forces and physical processes are such that black holes do actually form. So astronomers have known for at least 50 years that black holes exist in the universe and have had good evidence for this. But this is the very first time that it's been possible to actually take a direct image of the event horizon around the black hole. So the very, very, very central part. So this is very exciting.
So what we're seeing is the event horizon more than the black hole itself. Explain what and maybe there's the other image that would help with this. What is an event horizon?
Well, let's begin with this image. So it actually shows several different things. So the definition of a black hole is a region from which light cannot escape. So you actually see a dark region, and that's because there is no light coming from there. Any light particles that would exist there would not be able to escape the gravity of the black hole. So seeing this very dark spot is really the crucial part of this image. Now that ring around the dark spot is called the photon ring. So this is actually because of a process called gravitational lensing. So light that comes from outside the black hole, so that can escape, actually gets bent by the gravity of the black hole, and the black hole acts as a lens that produces this nice ring. Now, in addition, what you see is that one side of the ring is actually brighter than the other. And that's because around this black hole there is gas which is orbiting around, and on one side of the black hole the gas is coming towards us, and on the other side it's going away from us. And there's a relativistic effect that's predicted by Einstein's theories of relativity called relativistic beaming that makes one side brighter than the other side. So there are several things that are evident in this image that actually confirm theories that astronomers and physicists have had for almost a century, since Albert Einstein put out his theories of relativity.
What you describe is almost two-dimensional. The thing in the center and stuff swirling around, and we're able to view it as if from the top. I'm surprised it's not a sphere of material spinning around and being sucked into the black hole, in which case you wouldn't be able to see it, I suppose.
Right, so the definition of a black hole is an area from which no light escapes. So when you see something, you always see stuff that is outside the black hole. So what happens is a black hole has a lot of gravity, so material in the neighborhood, like gas in the center of a galaxy, as in this particular case, has a tendency to fall onto the black hole. But the gas is rotating, and as it rotates, it settles into a disk, like a frisbee. So there is a disk of material that forms around this black hole, and as the material gets squeezed into a smaller and smaller region, it actually, because of friction, it gets very hot. So it starts emitting X-ray emission. So we've actually known of the X-ray emission from this black hole and others for many years, but this is the first time that we can actually directly see the area around the black hole.
And we should say this isn't exactly a photograph. If we got close enough with your iPhone, it wouldn't necessarily look like that.
No, it's actually quite amazing. So Hubble Space Telescope has actually taken an image of this galaxy as well, and you can see in that image some features that directly point at the presence of a black hole here. And in fact, some of those features were known already 100 years ago, but not understood at the time.
This is the image we have of the particular galaxy. It looks like a star field.
Correct. That is, if you have the image, you could pull it up on the screen. That's the image. So what you see here is a galaxy. This galaxy is called M87. A galaxy is a collection of stars. So our sun is a star. Stars pull on each other because of gravity, so they tend to occur in groups. Our sun sits in a galaxy called the Milky Way galaxy. But there's many other galaxies out there, and this is one of them. It's called M87. It's about 50,000 light years away. In the very center, you see a bright spot in this galaxy. And from that bright spot, you actually see a jet of material coming out.
Looks like a streamer.
Right, sort of to the right. So this bright spot in the center has told astronomers for many years that there's something very energetic and powerful going on. And the energies involved are such that a black hole is really the only object that can efficiently enough turn matter into energy, produce the amount of energies observed. So there's been good reasons to believe there's a black hole in this galaxy, and it's actually been possible to measure how fast the stars in this galaxy are moving, and you can determine from the velocities of the stars how much gravity is pulling on them. So we've even known already for many decades that the black hole in this galaxy must be several billion of times the mass of our sun. And with this new image that's now been obtained, where we directly see the event horizon, we can actually measure the mass of the black hole even more directly. And it turns out to be 6.5 billion times the mass of our sun.
Let me run an email question by you. This is from someone who teaches a microwave course at Johns Hopkins. What frequencies were used to observe the black hole radiation?
Right, so the radiation observed here was millimeter wave radiation. So it's closer to, say, radio waves than it is to normal light, but it's all the same phenomenon. The frequency of the radiation is directly tied to the wavelength through simple formulae related to the speed of light. To make this image, as you alluded to earlier, you don't just take out your iPhone, and even something as powerful as the Hubble Space Telescope, which sits above the atmosphere of the Earth, can't observe something this sharp. So what astronomers actually did is they used radio telescopes, millimeter wave telescopes, in different places around the Earth, and they observed this galaxy all at the same time, and then they recorded the data streams with very accurately marked timestamps on hard drives, petabytes of data. And those were then later put together and correlated to build one image as though it had been a single telescope the size of the whole Earth. So by simulating a very big telescope, they were able to get a very sharp image.
You know, I think these are fascinating for people because it's almost like science fiction. it's hard to imagine. And you feel like there's potentially another world there. We were talking before the program about what the black hole actually is, and I had imagined that it was like a waterfall. When something got to the edge, the event horizon, and it got sucked into the thing, it was instantly in this impossibly compressed, weighty thing. That's not what scientists believe it is.
Right, so a black hole so gravity wants to make objects fall together. So for example, the sun, in the sun there are two things happening. Gravity wants to make the sun shrink, but there is nuclear fusion in the center of the sun, which produces energy, and the energy needs to go outward, and that produces an outward force, and that creates a balance. When a balance like that falls away, for example, when a star runs out of fuel, then there's still gravity, but there's no force left that can balance that gravity, and then the object starts collapsing. And sometimes when the object is massive enough, it'll collapse all the way to a black hole. So all the material will fall into a central point of almost zero size and infinite density. Now, around that is a region defined by what we call the event horizon. So if you're inside the event horizon, you can never escape this object. The laws of physics don't allow it. If you're outside, you can still escape. But it's more like a hypothetical boundary. There's nothing that actually changes there. So the black hole itself is really an almost infinitely small object. And the size is really determined by the size scale at which the forces of quantum mechanics become the same as the forces of gravity. And the physical theories that we need to describe those scales are actually still out there and still elude us. And things like supersymmetry and others are good options, but we really don't know what the theory of physics is that dominates what happens at those scales.
I guess it's like, I don't know, it was 5 or 10 years ago where the first planets were discovered outside of our solar system, orbiting other stars. And all of a sudden there was a cascade of discoveries. Will it be like that with black holes? Now that we've sort of seen one, I'm sure there are others, billions in fact, right? We'll be able to see more and understand them better.
So this group will certainly keep doing similar observations and take images of more black holes. I think the revolutionary aspect here is not that we know there's a black hole, we actually already knew that in this galaxy, is that we actually get to see it up close. So we can test our theories much more accurately. One of the interesting findings thus far is actually that this image can be explained and understood extremely well just with the sort of traditional theories of relativity proposed by Albert Einstein. So physicists have speculated for a century that maybe there are slight modifications that are needed to the theory, or there are slight differences that will only show up when we start looking at really special objects like black holes. Thus far, this image doesn't provide any evidence for that, but additional observations will certainly shed more light on that.
Let's take a phone call. Washington, D.C., this is Brian. Brian, thank you for calling. Go ahead.
Great, thank you. My question is whether or not they think there's any relationship between black holes and its impact on string theory.
Thank you very much.
Well, so black holes are actually a very good testing ground for theories like string theory. So a black hole is defined really purely by the force of gravity through the theory of relativity, which includes only gravity. But Stephen Hawking actually demonstrated some 40 years ago that there are actually quantum mechanical processes that operate around black holes that produce something called Hawking radiation. So to really properly describe everything that goes around a black hole, you need a theory of physics that includes both gravity and quantum physics. String theory is one such theory. So black holes are good testing grounds for people that make theories such as string theory. But there are many other theories out there. And ideally, by continuing to study black holes theoretically and by learning more about them observationally, we may at some point be able to discriminate which theories that physicists put forward are the correct ones and which ones may appear nice on paper but aren't realized in the real universe we live in.
The theorized existence of dark matter, I don't know if that's been proven or not. Is that a separate concept from black holes? Is there any relationship?
Yeah, so our universe is made up really predominantly by three things. Normal matter, like the matter that we humans and the table and everything consist of. Then there is dark matter, which is material with mass, but it's not made out of the same particles that we're made up of. But there's also dark energy. This is an energy of the vacuum in the universe. So those three components make up most in the matter of the universe. Black holes don't really contribute a very significant fraction to the total mass of the universe. But they do form from normal matter. They can contribute some to the amount of dark matter that we know in the universe, defined as matter that we just can't see. It's not luminous. So, but we do know that the majority of the universe is not made up of black holes.
What are you most excited about in terms of researching that galaxy, the idea of black holes? What do you hope to learn in the next decade or two?
Well, so black holes are really some of the most mysterious objects in the universe because of their strong gravity, because of their mysterious properties, the bending of light, the connections of space and time around them. You know, it's hard to imagine a weirder place in the universe. And the great thing is we can not just only study them in theory, we can actually observe them. We can build very fancy telescopes, do great technological things to actually try to understand these objects. So I've personally worked on this particular galaxy and the black hole in the center for almost 30 years. It's really great to see how far the field has come along. And by doing more of this kind of work,
Professor,
we'll try to understand everything there is.
Singularity approaches. We're almost out of time. Thank you very much for being with us, and thank you for watching Direct Connection.
This program was made by MPT to serve all of our diverse communities.